is tomorrow, and the next day, and the next. And then the day after that. So let's circle back. We were having some issues. Let's verify. What we downloaded is fully here. So I've got the SHA-256 code here, because I clicked this download before. And I just did a simple command, SHA-256 sum, and then my file. And it returns an OCA 644 and 66 OD2. Yeah, 66 OD2. Okay, so my file is legit. Next, what the heck am I doing wrong? Go to the Linux place, how to set up a Raspberry Pi with Linux. Extract the image. Okay. Maybe that's my problem. I was trying to use DD to directly extract and deploy the image to the SD card. Oops. So we go to the downloads. We unzip. The full image. Well, crap. Yes, thank you for letting me know. Let's delete some things. Well, that's kind of a fun, pretty graph. 28 gigs in my home folder. 12 gigs in my downloads. Some games. Some books. Some documents. Oh, ABBA. Yeah, I could probably delete the ABBA discs. It's not like I listen to them commonly. Hmm. Much better. So that command cleaned up the cache on the things. We want to document that command. Simple. You sudo apt get clean and you check it with disk usage. Okay, can we get back to what we were doing before? Okie doke. And then instead of the zip, instead of that, we want the other one. .img. And it's of the MMC. So we now have hopefully the right one. And hopefully this will work now. Oh, that was huge. All right, got a Raspberry Pis. One change from the other day, found this power line over Ethernet adapter. So I've got that connected up to the Pi, and I've got that plugged in the other room. So it makes a magical network connection, only 100 meg over Power. And there we are. America. Still have the same IP. Oops, forgot to set up SSH. There we go. And because we had to reinstall, obviously, the fingerprint is different. Follow the instructions. Yes. Yes. Okie dokie. Check the config. Look for any kind of... It looks fine. I don't see anything with the DT overlay, DT parm. DT parmesan. Nothing's enabled. Referring back to our instructions that we made earlier, we want to git clone. We want to CD to the Facebook. Then we want to make a build folder. And then go into the build folder. And then we want to CMake and all those options. And those options were, we want to set the clock divisor to 6, the statistics to 0, the DMA transfers on, a space in the 2 dots. So copy that, come down to your terminal, Control, Shift, and V. It pastes it in, we hit enter. Ooh. I forgot we installed CMake first last time. I also keep forgetting that I'm not root. Now that that's done, let's try that again. There we go. It's doing the thing. And then we make J, like me. So this is the second time I'm making something. Woo! And then we want to go into nano and edit the rc.local file, and we have to be sudo to do that. Sudo nano etc rc.local, and then we want to go down to right here above the 0, and we want to put in that. Oh, we need to run this command is being run at startup. We need it to actually say sudo in front of it. Sudo. All right, we exit, save it, and then what do we do now? Ah, yes, sudo nano boot config. We want to go down to our HDMI stuff, HDMI group 2. So these are the changes that I put in. We're going to go exit, save, enter. And now, let's shut it down. And I'm going to unplug power. And plug in the screen. Plug back in power. I still have the HDMI plugged in. We'll see what happens. It's a no-go. Let's see what's going on. I'm going to comment out all these. We must unplug the devices. Well, it's doing something different now. Nothing. I mean, at least we can SSH in, if only to shut it down. Plugged in again by HDMI with the hat on. I mean, what if we just run the command from SSH? Well, that kind of explains what's going on. Okay, never mind. I went to the builds folder again, and there's a program in there called FBC. I never checked. Is this how you do that? Wait a second. Before we do that, why don't we just do... Okay. Let me explain what that meant. So I did an ls-l, and it lists all the folders in the build directory. And it came up with all the permissions for each of these files. And these are separated into 3 groups with multiple items. I'm looking at the execute property for FBCP. So the way that that's set up is that it's a user for the first set, group for the second set, and then others. And you can set a read, a write, or an execute. So the execute bit has been set for all of those, so I know that I don't need to do a chmod command. But if I did need to set the execute bit, then I would be able to do that with the chmod command. All right, so now I want to run this. So where are we? What's our path right here? So okay, so we're going to sudo home hi fb build, and then we're going to run the fb thing. So right now, that should be, all right, initializing display, running main media stuff, 1024 by 1280. Output SPI display is 320 by 480 with a drawable area of 320 by 480. Applying scaling factor, yada yada yada. Creating disman resource. GPU grab rectangles offset 00 size 320 400. Okay. So is it running over here? It is not running over here. So I don't really know. What do we need to do? Well, I mean, this runs when I ran that command. So let's just make sure that that's set in the boot up. Home, pi, fpc, build, fbc, run it, and exit. All right, so it is being run, but whatever it's running does not work. So we'll get back out of there. We'll go back into our boot config. And we're going to look at some things. So I think what we should do is just try one of these one at a time. Or should we? All right. In the top of the config, it says go to rpf.io/config.txt, which takes you to the raspberrypi.org website, and you can read all about the things. The things that caught my interest was all the different HDMI modes, explaining somewhat what HDMI mode 87 is. So if we were to break down these changes one by one, we are looking at, where is it at? All right, so HDMI group number 2. Group 2 means DMT, which is display monitor timings, the standard typically used by monitors. Okay. HDMI mode 87. HDMI mode has to do with the resolution frequency and other details. Oh, display mode's not listed here. How to create custom HDMI modes. You issue an HDMI CVT command. Okay. So we've got that command, 480 by 320, number 1000. 480 by 320, 1000. Not listed. Frame rate in hertz. 1 hertz? I don't know about that. Aspect ratio we're ignoring. It's going to be, well, it's a 0. So it's ignored. Margins, disabled. Interlace, nothing. RB 0. Do I have the correct number of things here? 480, 320, 1. Frame rate is 1. I missed something. You probably were screaming at me since the beginning of time. I missed the 60. Okay, let's put that in, see if that makes a difference. We have the 60 in there now. And now let's do Control X. Save it. Yes. So, let's shut down and restart. Reboot the thing. Plug it in. Get the splash screen. And we wait. Ooh. I just saw some blinkage. What's going on? Meow, meow, meow. Okay, so at least we can confirm that the Raspberry Pi will boot. It just gets a white screen. My issue with the stuff last time was just that my config file was missing that 60 hertz. I was saying 1 hertz, and it just didn't like it. I take that back. Yes, that's why it was not booting, perhaps. But I also forgot to uncomment them. Let's try this again. Save it. Now reboot it. And we told the system to reboot, and Plymouth-reboot service did run. And then there was nothing on the screen. And so we unplug and we contemplate life, the universe, and everything. Do we just give up at this point? Ooh. Auto detect. Cannot display this video mode. Optimum resolution, 1280 by 1024. I think it could be outputting the correct resolution to our HDMI display, and it is just not working on this crappy $13 eBay dealio. I think I just unplugged this while it was running. He had something in there about setting it to 640 by 480. So let's go ahead and do that. And now we reboot again. This is getting old. Plug back in. Looking down the broken highway. Let's recompile it again with a speed of 30 for the clock divisors. Huh? Oh. Oh, wait a second. Okay, let's see if something has changed. No surprise. We can try rebooting. The following LCD please have been tested. Okay, let's do that. Let's go there. October 25th. Scroll to the bottom. 7 days ago. So is it just the fact that I'm an early adopter? Here's also some feedback. The designer of this library file, he says there's some differences about it. It's a 3-wire display versus a 4. A lot of the bandwidth is lost. He spent a lot of time on it, working on things. And basically is saying that the only good thing about the MPI 350, which is the driver inside of this display, is that it makes the IL, that one, look like a Ferrari, and the HX 83 look like a jet airplane. So the display I have is slow. 7.5 frames per second. So, yeah, that's not very good. We also notice the way that the hardware works prevents the use of DMA. We noticed that when we ran the code, it says it's disabled. So it's actually overriding with this library when I do CMake. So this is not helpful either. So even though he had implemented it 7 days ago, he had a different tree of this, which I'm going to try to utilize. All right, I'm a noob to Git, so it says that you can use git checkout and the commit hash. So that was the one 22 days ago with the working code on that branch. So I'm in the folder, and what does this say? Okay, Mark Longuer, very helpful. This will give you a warning. You're in a detached state. And that's fine, because I'm looking to use it rather than actively develop it. Beautiful. So now, hopefully, I can just make this whole thing again. And because we know that DMA transfers doesn't work, and I don't care about statistics, let's just go with a simplified. We're going with the Ketty, clock divisor 30, go. I think we have to clear this first. So, buttons. Before I get back to that, just did a little bit more reading. The Ketty 6.3 takes the crown of being horrible in all aspects. So, stay clear of the Ketty or MP3150 displays. So I'm not surprised it's not working. Yeah. We should just stop here. However, we'll give it the college try to try and attempt to get it to work one more time. RMRF build. Ugh. What is this? Ah, come on. All right, what's this saying? This is because of that git command that I tried to run. It doesn't recognize its own display. So we're going to roll it back by just uncommitting. And to do that, we go back to the branch master. We get the SHA Bingity bongity bongity. And paste-a-rooney it into the what's a who's it. We do RM, RF, build. Oh, from the build folder. RM, RF, build. Make it again. Make -J. And then we should be able to run the thing. Nada. That's different. Haven't seen that one before. I also ran the RMF thing from the wrong spot. We need to remove the folder, because that's what the command does. Remove folder, build. And now we need to mkdir, build. And then we need to go to cd, build. And then we need to run it again. Where is it? We do that again. The whole 9 yards. And then we do a make -J. And then when we made it, we run it. Okay? We tried. Restarting, just in case. Well, I mean, that's more information than we had. I mean, clearly, there is something operating. Because we can get changes in the display. It's hard to get the thing going on there. I can't show you, but it is changing. Well, I gave it one more try. I even forced turbo mode, but still no good. No worky. And that's that. I'm going to call it. I have yet to be able to even to get this screen to display, and I just suspect that it is going to be too slow anyway once we got it working. But we haven't gotten a working display yet. That was kind of the whole point. No, it wasn't. The point was we struggled. We figured out a whole bunch of different things. I mean, think about all the notes that we took trying to figure this out. This is all things that we learned about. We learned how the interface on here, being an SPI interface, is limited by the frequency that the processor can put out, and the fact that the way you get around that is by limiting the amount of updates, so you update just the changes. We learned that I mean, you can remotely connect your Pi by SSH. I learned that there's a process of reading before you start typing random stuff on the command line. Now, this is just some random Raspberry that I've been nibbling on, so that's why it doesn't really make a difference. But, you know, we went through the make process. That was kind of new. Figured out some stuff with how to modify the boot config and the rc.local and how that works. Reiteration that I need to type sudo before commands. You know, and And this is all great stuff. Type sudo, you know, like simple stuff like that. So this was not a wasted effort at all. I totally enjoyed this experience. It's a shame that we did not get to our stated end goal. If we were to somehow move forward from here, I think we would go down to this little chart and find the fastest display, or at least a display that refreshes at, you know, around the 60 frames per second. So we've got the Adafruit one, we've got the buydisplay.com, that's a little small, that's a little small. That one, the Tontech, he said that these must be out of service because they are no longer available. Got another Adafruit. So, the biggest screen we can get is the Adafruit Pi TFT at 21 frames per second. So it looks like the smaller ones work better. Or, yeah, that's what it looks like. Actually, these are the best? Is that what he's saying? What's this? What's this? Oh my gosh! Someone new open box. Well, I'm lucky. I don't know about you. I mean, sanity check. The 480 by 320 3.5 inch LCD from Adafruit is only $45. And I have already spent $18 for buying this one. And then for this cheap one, I paid $11. We're really getting close to that $45 for a screen that you actually know works. And compare that with the $29 for the WaveShare 3.5, which is stated to have a 12.9 frame per second refresh rate. But at the same time, that frame rate column shows the worst case frame rate. So that 12 frames per second actually may not apply, especially if you're using it to play old school games. It's going to end up being very fast. I mean, if you wanted to just go all in, you could just go ahead and buy something that's ready to go. I mean, I don't know what this is, but it appears to be the same display. And it's only 19. Alright, it's not the same display. I don't even know what that thing is. This is the backside of the one that's on his GitHub. Of course, it's European. But it's the B version of the display. I don't know, folks. I think that if you really want this to go, you might as well buy a quality product from someone who has tech support and makes nice hardware. And, I mean, they're local to me. USA. So what if we want it to just work? What if we just want to download it? Well, we can go to the Keddy website. And they have a bunch of different options. And I'm going to download the driver, but I'm going to do that over on the Raspberry Pi. So I'm going to create a folder over here. And then we are going to wget the location. Oh, well, before we do that, maybe we'll go into downloading. Finish downloading, and now we do a tar xvf lcd it unzips it, or untars and ungzs it. Once it's done, go to the folder. Show what we got. So we've got LCD 35, it looks like. All right. Oh. You gotta do it the right way, right? Oh. I don't think I have permission to do this. Well, before we run this, we need to go disable all the other stuff. And when I mean all the other stuff, I just mean this one line. Save it, kaboot it. And now, LCD. I don't know what else to do at this point except run it. Oops. Come on. Okay. Lowercase v? Lowercase v. That made all the difference. Oh. It's doing something. Disconnected. So we plug this in again. I'm back to using the monitor as the supply. Just saw the flash screen, splash screen. Alright, I saw the raspberries over here. So this display does work. It's just wicked slow. Gosh, if we just started off here at least, we'd have a reference. This is impossible to wrangle. Well, it works, but it's very slow. And I'm willing to bet that we can barely even play anything. We're going to load up the squirrel game. Oh my. It is very tiny. Where's my squirrel? Oh, there's my squirrel. Bloop, bloop. Oh, I got eaten. Do, 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 do. Do, do, do. I don't know. I mean, this functions. It's not great. I can tell that the whole screen is pretty slow with the refresh rate. Not great. I mean, I guess the nice thing is that the touchscreen actually works too. Not great, but it is functional. I mean, what were we going to do with this thing anyway? I mean, I guess I can do this. Oh, yeah. This is abysmal. So, we got it to work in about 5 minutes using the stock drivers, but we did not get it to work with the fancy drivers. I'd say the wave share or the Adafruit are your best bet. So your wave share was $29 and your Adafruit was $45. And your time spent Well, gosh. I think I started this on Friday. Who knows what time it was? It was midnight when we finished the first part 1. So, this has been fun. See y'all next time. Subscribe.